I'm Jonah with Magnanimous Media, and this is the Bartech Wireless Follow Focus.
In this video, we'll cover some of the uses for wireless lens control, selecting receivers, powering the system, setup, calibration, and general practices. The Bartech Focus model is a single-access wireless lens control system designed for wireless focus control. The relatively low noise, low weight, and performance allows the Bartech to be amenable to a wide variety of cameras, lenses, and support systems, such as the Movi M10 and Steadicam. The biggest advantage of the Bartech is its simplicity and durability.
Wireless lens control is appropriate for a number of situations. Steadicams or gimbals like the Movi M10 won't allow an AC to pull focus manually or touch the lens during operation, so a wireless system is a necessity. Don't forget that you're using systems like the Steadicam or the Movi to enable complex moves, so you don't want to be limited by an inability to pull between focal points. This is also true with cranes or jibs where the camera may be out of reach, though you may want to consider a 2 or 3 axis system so you can control the iris and change focal length on a zoom. Handheld shots can also benefit from the Bartech, as a skilled AC will be able to more smoothly and accurately pull focus when compared to an operator who's trying to manually focus and also set frame. Another big benefit of wireless lens control is that it reduces the number of bodies around a camera, which is one reason why they're now commonplace on sets, even when not a requirement for the support being used. Traditionally, the first AC would pull focus based on distance with a properly back-focused lens, but more and more sets are going to a wireless video feed to an AC monitor, which allows them to preview the frame and anticipate focal point shifts.
With Magnanimous, you'll have the choice between the digital and analog receiver. The version 2-1 digital system has the ability to set custom limits and torque, and will automatically calibrate to lens ends, making it ideal for cinema and cinema-adapted lenses with hard stops. The analog receiver cannot set custom limits, but because you can set lens ends manually, it is ideal for lenses with friction focus rings. Keep in mind that the friction focus rings, used on many modern still lenses, may respond differently to fast versus slow turns, which may throw off calibration. It is best to be gradual and consistent with focus pulls with these lenses when using lens control. The Bartech package includes a receiver, Bartech focus device or BFD, antennas, power cables, mounting adapters, and an assortment of motor gears for different pitches. 0.8 pitch is standard with most cinema lenses and attachable lens gears.
Before we get into setup and calibration, let's talk about some of the requirements for using the Bartech system.
The Bartech is designed to be deployed on standard 19mm or 15mm rods, so a base plate or top plate with rod support is required, and the more rigid and straight the support, the better. You'll need at least one rod above or below the lens with about an inch or more of distance from the lens barrel. The Bartech requires 11 to 15 volts and draws a maximum of 5 amps when the motor is in operation. We may have power cables to accommodate powering the Bartech off of the camera's power outputs, but typically the simplest solution is to use a D-tap cable and power the system off of an Anton Bauer battery, such as a Hytron 50 or Dionic. Depending on the setup, this may also require an adapter or cheese plate and 15mm rod support that will accommodate the cheese plate. Whatever the power solution, make sure that you know the battery's safe voltage levels. Use a battery alarm and stay on top of battery swaps so you don't end up killing an expensive battery. The BFD is powered by a 9-volt battery. In most cases, a fully charged 9-volt battery will power the BFD for 60 hours of operation, but this depends on use. Most of the point of this system is staying untethered, but you can also power the BFD off of the power output on the receiver.
Setting up the Bartech with systems like the Movi M10 will require some special equipment and a little bit different setup, so consult with us on your intended use. To build up the Bartech, we'll start by attaching the motor.
If using 15mm rods, you'll need to make use of the 19 to 15mm sleeve. The motor can be attached on the smart side of the camera, though installing it on the dumb side is usually more advantageous for the operator.
When attaching the motor, you have to consider torque. The motor is powerful enough to potentially push the gear off at the hard stops, so minimizing this risk is ideal.
The best setup for torque is to attach the motor directly to the rod and adjust the motor so that the gear is close to the rods. The downside of this setup is that the motor may hang fairly low, so try balancing these concerns when building up. If you're using an analog receiver, then hold off on placing the gears on the lens, but with the digital receiver, you can place the gear against the lens when mounting the motor. Engage the teeth, but keep it from pressing hard against the lens. The Bartech receiver does not have any rosettes or mounting points, so Velcro and camera tape will be quite useful in mounting. When identifying a mounting point, it's best to mount it so that there is little risk of falling off and make sure that it is in reach of the motor cable. Keep in mind that you want to have easy access to the interface or calibration controls, which you'll need to access after lens swaps.
For calibration, we'll start with the digital receiver.
To calibrate, the digital Bartech moves the motor to each end of the lens, stopping on the hard stops. If the motor is attached after the receiver is powered up, then calibration will begin automatically. If this process does not start, or you've swapped lenses, simply press and hold the calibrate button until it begins to calibrate. Once calibrated, the system will hold this calibration even after being powered off, as long as the motor is not disconnected from the lens. If calibrating after a lens swap, it's advisable to keep the BFD powered off until calibration is complete.
In some cases, the calibration won't complete. This is usually due to a lens with tight controls and a low torque setting on the Bartech. To resolve this, you'll need to adjust the torque settings. To adjust the torque settings, you'll need the BFD.
Power it up, ensure both the BFD and receiver are on the same channel, then place the direction in the reverse position. You'll use the position of the focus ring to set torque. All the way counterclockwise is 1% torque, and all the way clockwise is 100% torque.
For heavy-built cinema lenses, you can use full torque, but this may not be advisable with lighter-built lenses such as Rokinon or cinema-adapted stills. Additionally, higher torque settings will generate higher noise levels.
Once you've set the focus control in the desired position, you'll press and hold the torque button on the receiver until the status light turns off, then turns back on. The color of the torque light indicates the level of torque. Green is low, orange is medium, and red is high torque. If adjusting torque to solve calibration issues, press the calibration button and allow the motor to find the ends. If this does not solve the issue, then step up the torque and repeat calibration.
Another feature of the digital receiver is custom limits. Custom limits allows you to limit the range of the motor to a certain range of the lens and then spreads that range to the entire length of the controller. This will be useful in accurately pulling between two distances or slight pulls that need to happen over a long period of time.
You'll start with the properly calibrated system. To set control limits, first use the BFD to place the lens in the desired start point, then press and hold the limits button until it starts to blink orange, then release. This sets the first soft stop point. Move the lens to the next desired point, then press and hold the limits button until it is solid orange. While custom limits are in place, the limits light will remain solid orange. It is possible to use this limit function to set lens ends for still lenses with infinite focus rings. However, the analog system will be much more forgiving and often faster with these lenses. To release the custom limits, simply press and hold the limits button until the light turns off.
When calibrating the analog system, it's important that you follow the proper procedure precisely. The motor has a lot of torque. There is no safety or torque control, and the motor moves at full speed between endpoints, so improper calibration could lead to damaging the lens or the motor.
The analog receiver is calibrated manually by making use of two endpoint adjustment wheels and the 3-position toggle switch. Start with the system and BFD off, the motor disengaged from the lens, and the toggle switch in the center position. Adjust both of the endpoints as far in as they will go, rolling them towards the toggle switch. Next, power up the receiver with the gear still disengaged. Flip the toggle switch towards one of the endpoint wheels. The motor should move to the center of the desired range. Move the lens to the center of the focus range, not by distance but by travel. Now you can engage the motor to the lens.
From this point on, it's important that you do not move the endpoint adjustment wheels while the toggle is in the center position. You should always be able to control and observe the response of the motor when adjusting your endpoints. If you accidentally move a wheel without that endpoint selected, you'll have to restart your calibration.
Next, you'll move to the end. Using the wheel that you move the toggle switch towards, slowly roll it away from the toggle switch. The motor will move the lens towards the endpoint. Be slow and gradual. When you are reaching the end, avoid going past, which could damage the lens or motor, but will more likely jump teeth first. If the motor gear disengages or jumps teeth at this point, you'll have to restart calibration. Once you've found the desired end, you can calibrate the other hard stop. Move the toggle switch all the way to the opposite side, towards the other endpoint wheel. The motor should move the lens back to the center of travel. Roll the endpoint wheel away from the toggle switch, which will move the lens towards the opposite endpoint. Again, be gradual and do not go past the end. Once both ends have been designated, you can place the toggle switch in the center position as calibration is complete.
After you've completed calibrating, it's a good idea to tape off your adjustment wheels.
You'll still need to access them for lens swaps, but it will reduce the chance of accidental or absent-minded calibration errors.
When swapping lenses, you'll need to repeat this process from the beginning. Taking shortcuts on this process is not worth the risk and will often lead to calibration being more time-consuming.
The on-off switch is on the left. The direction can be changed to forward or reverse depending on preference. The data out port allows for direct control of the receiver.
Another feature on the BFD is remote start-stop. Start-stop control will require gear specific to the desired camera, so consult with us before planning on having this feature. Remote start-stop will benefit crane shots, as you can roll on the camera when it's in position, rather than burning away film or wasting data while the camera is moved into the first position.
On the BFD, start-stop can be set to momentary trigger or continuous trigger, depending on the needs of the camera. Then, the camera is triggered and stopped via the toggle switch on the upper right.
Now that you know how to set up and operate the Bartech, we can talk about a few general practices and considerations when using a wireless lens control system. As I mentioned before, the first AC is tasked with pulling focus, among other responsibilities. The AC is pulling focus based on distance indicators on the lens, which requires proper back focusing, also marked points on the follow focus, and sometimes a visual reference.
A lens with proper back focus ensures that the distance indicators on the barrel are accurate, including the infinity indicator. After calibration, the AC will use a dry or wet erase marker and move the lens through these indicators, marking the follow focus, which gives the AC distance indicators on the follow focus. The strip on the follow focus is removable, so if you have additional strips, you can do this on the prep day with each lens in your set and save the strips for when those lenses are in use. Otherwise, you need to allow time for the AC to perform this task after lens swaps.
The AC will also need to know what's happening in the shot, so they know what to pull to and have proper preparation to do so. Discuss every shot with the AC, point out focal points, timing, and moves. Then rehearse the move, allowing the AC to find critical focus and mark those points on the follow focus. This is the reason why the phrase "shoot the rehearsal" is not welcome to the AC, and also why you should consider stand-ins for complex takes. So that is the Bartech wireless follow focus system. It's certainly a great option for wireless lens control, especially when you're on a tight budget. For more news and tutorials, check us out at magnanimous.biz.